Hi, I'm Miss Ginsburg with KnowAtom, and today we're going to be reading Electrical Energy. This is a student reader in Unit 7. Electric currents. Reading with a flashlight. Adriana's sister is already asleep in their bedroom. The room is dark, but Adriana isn't tired. She's in the middle of an exciting chapter in her book. Adriana covers herself with her bed covers. She turns on her flashlight. She keeps reading. Time passes. The flashlight bulb gets dimmer. After a while, the light shuts off completely. Adriana has to stop reading. The flashlight won't turn on again until Adriana puts new batteries into it. Flashlights need batteries to function. Electricity and matter. The flashlight needed new batteries because batteries are a source of energy. Batteries hold stored chemical energy. This energy turns into electrical energy when the batteries are put into a device such as a flashlight. Flashlights use the energy in the batteries to produce electricity. Electricity is the flow of electrons through a conductor. Electricity happens because of the atoms that make up all matter. Remember that atoms are tiny particles too small to be seen. They are made up of even smaller particles. Electrons are one kind of these smaller particles. Electrons have negative charge. This is a model of an atom. Conducting electricity. In some kinds of matter, electrons can move from one atom to another if they are given a push of energy from an outside source. Materials that allow electrons to pass through are electrical conductors. Electrons always move in the same direction as one another in an electric current. Metals are common conductors. Silver, copper, bronze, and aluminum are all metals. They are good electrical conductors. Some materials don't allow electrons to pass through. These materials are electrical insulators. Glass, rubber, plastic, and ceramic are good insulators. This diagram shows electricity moving through a conductor. The green outer covering of the wire is an insulator. Electricity in a flashlight. The energy stored in the batteries powers the flashlight because there is a circuit inside the flashlight. A circuit is the circular path that electrons travel in a negative to positive direction. All circuits have the same basic parts. All circuits have an energy source, such as batteries. The battery provides the force that pushes the electrons in the conductive material through the circuit. All batteries have a negative end and a positive end. Electrons travel from the negative end through the circuit to the positive end. They move because the negatively charged electrons are attracted to the positive side of the battery. This attraction pulls the electrons toward the positive side of the battery. A dead battery is one that can no longer pull electrons. Circuits also have wires. Wires are the paths that electrons travel in the circuit. As they travel, the electrons carry electrical energy from the battery. Energy moves from the battery through the conductive wires. The wires in a circuit are attached to an object that can convert electrical energy to do work. Work is any change in position, speed, or state of matter due to force. For example, a light bulb is an object that does work. When electrons reach the light bulb in a circuit, they transfer electrical energy. The light bulb changes the electrical energy into light energy and heat. A motor is another example of an object that does work. A motor is a machine that converts an input of energy into an output of kinetic energy. When a motor is part of a circuit, it changes the electrical energy into kinetic energy. All circuits must include something that can do work. Without this part, the electricity will overheat the circuit. This is called a short circuit. It is dangerous. Finally, most circuits have switches. The switch opens and closes the circuit. Electrons flow when a circuit is closed. When Adriana turns her flashlight on, The switch closes the circuit. Electrons flow from the battery to the light bulb. The light bulb turns on. Electrons cannot flow in an open circuit. When Adriana turns her flashlight off, the switch opens the circuit. No work can be done in an open circuit. Direct current. There are different ways that circuits can be designed. For example, a simple circuit has one path and one object that can do work. A series circuit uses one path that has more than one piece of work. A series circuit has one path for electrons to travel, but multiple light bulbs. This means the electricity moves from one light bulb to the next before it returns to the energy source. If one bulb stops working, it breaks the circuit. The electricity cannot continue on its path. Both the simple and series circuits we have been talking about use direct current. Direct current is electric current that constantly flows in one direction from a negative to a positive charge. Batteries always create a direct current. The electrons always flow from the negative side to the positive side. DC, or direct current, is useful for carrying electricity over short distances. Here's a simple circuit, and here's a series circuit. Alternating current. Alternating current, AC, is electrical current that changes its direction many times every second. Alternating current is easier and cheaper to send over long distances. Power plants use alternating current to send electricity to homes. When you plug in a lamp or a phone to a wall socket, you use alternating current. In the United States, alternating current is generated at 60 hertz. 1 hertz is equal to 1 cycle per second. This means the current alternates its direction 60 times in 1 second. Power lines use alternating current to send electricity. Electric cars. Powering an electric car. Chad owns an electric car. In 2010, Chad took a road trip. He drove from the state of Washington to California. He never had to stop for gas. Instead, he plugged his car into electrical outlets he found in campgrounds. This is similar to how you charge your phone. Electric cars have electric motors. They don't need gasoline or diesel to run. Instead, they use electricity to make the motors turn. These electric cars are plugged in and charging. How an electric car works. The electric motor is part of a circuit that includes a power source, such as a rechargeable battery. The motor spins when the circuit is closed. The motor spins as the electrical energy turns into kinetic energy. This spinning provides an unbalanced force that makes the wheels move the car. The motor is connected to an axle using gears. This motor axle is called the drive shaft. The drive shaft is connected to another axle that is connected to the wheels. The wheels spin when the axle spins. All of the parts on the vehicle are placed to balance the car's weight. If a vehicle's center of gravity is too high or too close to the front or back, it is unbalanced. This might cause it to roll over when going around a sharp turn. This diagram shows the basic parts of an electric car. Got the battery, the electric motor, the wheel, motor axle or drive shaft, axle, and gears. Designing an electric car. All objects have a point inside them that is their center of gravity. Imagine trying to balance a ruler on your finger. The point on the ruler where it balances is the center of gravity. However, the center of gravity is not always in the middle of an object. Imagine trying to balance a hammer on your finger. Your finger will have to be closer to the heavier part of the hammer to balance the hammer's weight. The lower your center of gravity is, the easier it is to keep your balance. Think about leaning over to pick something up. It's easier to stay balanced if you're sitting in a chair and you lean over compared to if you're standing up. Cars are designed low to the ground, so they have a low center of gravity. Every object has a center of gravity. It isn't always in the middle of the object, though. So here, the ruler center of gravity is in the middle, but the hammer center of gravity is all the way over here. Friction and cars. People who design cars also have to take into account friction. Friction is the force that slows motion when two objects rub against each other. Friction makes the objects slow down because the kinetic energy that powers their movement has changed to heat. Friction between the road and the tires is called traction. Cars have tires with treads that are designed to grip the road. This traction is important. It keeps cars from sliding all over the road. This is similar to how the friction between your shoes and the cement stops you from slipping when you run down the sidewalk. When a driver pushes on the brakes, the friction between the brakes and the wheels slows it down. Tires with deep treads make the surface of the tire rougher. This helps tires grip pavement. Some cars use rear-wheel drive. Rear-wheel drive sends power through the rear wheels. Rear-wheel drive offers the best traction for acceleration. Acceleration is an increase in speed over time. It is measured in meters per second squared. When the car accelerates, the car transfers weight toward the rear wheels and away from the front wheels. This extra force pushes the rear tires into better contact with the pavement. However, not all friction is helpful. It occurs whenever two objects rub against one another. The change of kinetic energy of the moving object to heat can cause objects to slow down or even stop. For this reason, axles are smooth to reduce friction as they spin. Rear-wheel drive sends power through the rear wheels. I learned a lot reading electrical energy, and I hope that you did too. I'll see you tomorrow with another one. Bye!